Hello, and welcome to Module 11.2a, Transformations of Quadratic Functions. This portion today is all about translations. Our objective is that I can apply translations to quadratic functions. Example 1, vertical translations of quadratic functions. The graph of g of x equals x squared plus k is the graph of f of x equals x squared translated vertically. So you remember we did some of this shifting when we were dealing with our exponentials unit. We were moving things up and down. We were moving them left and right. We were dilating them. We're going to do the same thing with with quadratics. So if our k value, if that value being added at the end of our equation, if it is greater than 0, we are translating that many units up. If it is less than 0, that is how many that we are translating down. So let's go ahead and look at the first example here. So we have f of x equals x squared, and that is the one that is graphed for you already on the right-hand side there. And we're given that g of x is x squared plus 1. All right, so we know we're doing vertical translation, so we're going up and down. So that means there's a couple things that we already have information about. Our axis of symmetry does not change because we're just going up and down. So we're just sliding it up and down along this line. The axis of symmetry will not change. Okay, that means my vertex also does not change. So I can start with 0 for my x-coordinate of the vertex, but my y-coordinate is going to be a little bit different. All right, so it originally is at 0, 0. So now we are shifting it. So we're going to go up 1. So what's happening to that 0? Well, 0 squared is 0, plus 1 is 1. So our new vertex is right there at 0, 1. So now let's find some points around it that we can graph. So I'm going to go to the right of the 0. We have 1 and 2. To the left, -1, -2. All right, so let's put it in. 1 originally, where was our original point for 1? Our original point was 1, 1. And let's see what all of these original points were. Our original point for 2 was 2, 4. And our original point for 3 was 3, 9. All right, so let's see how these have changed. 1 squared is 1, plus 1 is 2. So now we have a point at 1, 2 instead of 1, 1. We've moved it up 1 on the y-axis. 2 squared is 4, plus 1 is 5. Again, we're moving up 1 on the y-axis. So then -1 squared is 1, plus 1 is 2. -2 squared is 4, plus 1 is 5. So we can go ahead and graph these points now. So we had our vertex. We have a point at 1, 2. We have a point at 2, 5 now. And we're just going to go ahead and say 3 squared is 9, plus 1 is 10. So we'll just put that point up at 10. Okay, and we're going to mirror them across our line of symmetry. Right, we've got our points there, there, and there. And I'll use a thinner line to draw the curve in. But we can see it's going to mimic the shape of the original one, but it's going to just be a little bit higher up on the graph. All right, let's look at letter B. Letter B. We've got f of x equals x squared, and we've got g of x equals x squared plus 5. Well, we know we can really quickly do an x squared graph because we've graphed them a couple times already. We have 1, we have 2, 4, and we have 3, 9. Right? So that's going to be that, that's going to be that, that's going to be that. All right, that's our original. Okay, our vertex is not changing, so it's still going to be at 0 for the x-axis, the x value. Now, 0 plus 5. What is 0 plus 5 going to give us? It's going to be 5. So my new vertex is all the way up here. All right, so now we're going to do 1 and 2 and -1 and -2. So 1 squared is 1 plus 5 is 6. So we have a point at 6. And 2 squared is 4 plus 5 is 9. And I know it's going to be reflected to the other side. And I don't need really to calculate it, but you can. So we're at a point 1, 6. And we're at a point 2 and 9. Right? And we can mirror those across. Did we need any other points? No, we didn't need that third point on the side. And so we have our new graph there, shifted up 5 units from where we started. All right, we've got 2 U-try problems. Go ahead and do those 2 problems. Go. All right. Letter C, we have f of x is negative 2x squared. So we have one that is pointing down and it's graphed for you already. And then we've got g of x is negative 2x squared minus 3. So we can make an educated guess as to where we think our vertex is going to go. It was at 0, 0 originally. But now 0 squared is 0 times negative 2 is 0 minus 3 is negative 3. So our new vertex is at 0, negative 3, which is going to be right there. So now let's put in our points. We're going to go to the right, 1 and 2, negative 1, negative 2. So 1 squared is 1 times negative 2 is negative 2 minus 3 is negative 5. 2 squared is 4 times negative 2 is negative 8 minus 3 is negative 11. So negative 5, negative 11. Now let's graph those. We have a point at 1 and negative 5, and we got its corresponding point across the axis. And then we've got a point at 2, negative 11, which will be like right about that end line of our notes. And now we just draw in our curve. And we have our line, or our graph. All right, letter D. So again, we've got x squared, so we're just going to throw that in real quickly. 1 squared, 2 squared is 4, 3 squared is 9, negative 3 squared is 9, negative 2 squared is 4, 1. So that's our original, just as a reference point of what we're going to look at. And now we start off, our axis of symmetry is still going to be the same. Our vertex is still starting on an x value of 0. So 0 minus 3 is negative 3. All right. And now we need to find 1 and 2. I always defer to finding the positive values because then I don't have to remember about the negative signs, even though we're squaring. But you can do whatever you want. You can work all these problems out. You can type them all into the calculator. Just make sure when you are squaring a negative, you have it in parentheses. All right, so 1 squared is 1, minus 3 is negative 2. 2 squared is 4, minus 3 is 1. And so we have negative 2 and we have 1 as those values. All right, so 0, negative 3. So we're going to be down here. We have a 1, negative 2. We have a 2 at 1. Okay, so those are my points that I can mirror across. Now we're going to go ahead and draw in our graph. If you wanted to, you could put the value in for 3 there. So that would be 3 squared is 9, minus 3 is 6. So we'd have a point at like 3, 6. So I was a little bit off on the positive side, but I was pretty spot on the negative side. So it'd be there and there. I expect you to have 5 points identified on your graph. I don't care which 5 they are. All right. Let's take a look at the next page, where we are going to do horizontal translations of quadratic functions. So a horizontal translation of a quadratic function, so the graph of g of x equals x minus h squared, the quantity squared, is the graph of f of x equals x squared translated horizontally. If our h value is greater than 0, the graph goes to the right, and if the h value is less than 0, it goes to the left. Now let's pay attention here. When we say the h value is greater than or less than 0, we're talking about that right there. Okay? So practically, if we see x plus h, that's going to be a negative value. Right? So we're going to move that to where it should be. Right? So if it's x plus h, right? X plus h, right? That's the same as being x minus negative h, right? So those would be less than 0. if we have x minus h, right, as we see it there, that means h is a positive value. The sign didn't change. So that's an important thing to pay attention to. So these are going to be a little bit, just like when we did working with exponentials, these are going to be a little wonky, that they're going to want to, you're going to be a little counterintuitive in how you need to think here. All right, so just pay attention to those signs, and if it's x plus h in there, we know that that's a double negative that we're dealing with, and we have to move to the left. So that's exactly what letter A is. We have our vertex move, or everything moving to the left 2, right? Because this would be, if we wrote it as standard form, it's x minus -2 squared, right? So the h value is this right here. It's a -2, so we're going to the left 2. So that means everything that we graph is going to be to the left 2. Well, we've been starting with our vertex, so let's start with our vertex again, right? So our vertex is at 0, and we want to know what is going to happen here. 0 squared, 0 plus 2 is 2, 2 squared is 4. All right, well, let's see what happens on either side and see if we can find some patterns that we can work with, or if we need to change our points. So 1 plus 2 is 3, 3 squared is 9. 2 plus 2 is 4, 4 squared is 16. Well, those don't seem like they're going to super help us. Let's see what's going on to the left. We've got -1. -1 plus 2 is 1, and 1 squared is 1. Ooh, okay, we're going down. -2 squared, -2 plus 2 is 0. 0 squared is 0. All right, maybe we need one more here. So let's see, -3. -3 plus 1 is, sorry, -3 plus 2 is -1. Squared is 1. Hey, look, there's where we made our switch from decreasing to increasing. So we're going to graph these points here that we have. So -2, 0, which now if we're thinking counter, or if we're using our intuition, if we're saying we're moving to the left 2, this whole graph, then we could just take a point and go 1, 2 stops over. All right, let's graph some of the rest of these points. So at -1, we're at 1. At 0, we're at 4. At 1, we're at 9. Okay, well, if I know my axis of symmetry, and we'll use a highlighter on that. We'll use a small highlight. So my axis of symmetry is right here. So I can reflect these points. Even though I didn't calculate them, I can reflect points across. So the point at -1, 1, I can reflect that across, and I have a point at -3, 1. The point at 0, 4, I can reflect that across, and it's -4 and 4. And then I can put this one across to -5 and 9, and we have our graph. Okay, but what we can see, though, is we look at each one of our points corresponds 2 steps to the left, right? 1, 2, 1, 2. Each one of those points went 1 step or 2 steps to the left. Every single point did the same movement. Okay? All right, let's look at letter B. F of x equals x squared. So we know that one already. And let's quickly throw in our reference points just as a, keeping it in our mind of where we are originally. All right, so there's our reference points of f of x. So now g of x, it's x minus 4. So again, we're looking at this piece right here specifically. And so that is telling us we're going to move to the right. We're going to the right 4 units. Everything goes to the right 4. So if my vertex is at 0 and I'm moving to the right 4, we're going to start it at 4. We're going to do this a little differently. We're going to be smart about this. So if 4 minus 4 is 0, 0 squared is 0. So then we're going to have 4, 5, and 6, and we're going to have 3 and 2. All right, so 5 minus 4 is 1. 1 squared is 1. 6 minus 4 is 2. 2 squared is 4. And we can mirror that to the left side of our line as well. So we're going to have a point at, let's go to 2 and 4. Ooh, that kind of overlaps with what we had already. But the rest of the shape is not going to be overlapping. And you'll see why in a second when we have our points. So there we go. And we have our line. My left side's a little off, but it works for what we need. All right. So we've got our line. We see that we shifted 4 units to the right. Every single point, if we look point for point, we moved 4 to the right. Especially, it's most evident here. 1, 2, 3, 4, right? We got to that point that was on the right-hand side already. That's how far we moved over. All right, I'd like you guys to try letters C and D on your own. Go ahead and do those and then check your work against mine. All right, letter C, we have that same graph from yesterday. We have negative 2x squared, so we see that graphed for us. And then we need to graph negative 2 times the quantity x minus 3 squared. So again, we're looking specifically at that value. That is positive, so we're going right 3. And so if my vertex was at my origin, it's now 3 units to the right. So 3 minus 3 is 0. 0 squared is 0 times negative 2 is 0. All right. So now let's go through. We need 4, 5, and 6, or 3, 4, or 4 and 5, and we're going to need 2 and 1 to fill in. So 4 minus 3 is 1. 1 squared is 1 times negative 2 is negative 2. 5 minus 3 is 2. 2 squared is 4 times negative 2 is negative 8. 2 minus 3 is negative 1. Negative 1 squared is 1 times negative 2 is negative 2. 1 minus 3 is negative 2. Negative 2 squared is 4 times negative 2 is negative 8. So we're going to go ahead and graph these now. 1 and negative 8. So that's all the way down there. A 2 and negative 2. A 3 and 0, a 4 and negative 2, and a 5, negative 8. So we have our graph. There we go. 4 units to the right. It's the same graph. We just shifted it. We translated it 4 units to the right. 3 units to the right. Sorry. All right, now our next one, g of x, we've got x squared, and then g of x is giving us the quantity x plus 3 squared. So let's do a quick and dirty drawing of our values here. And there we go. All right, so let's go ahead and find it. So our vertex was at 0, and we're going, in this case, if we look at this, we have a plus sign, so we know that that means it's actually minus negative 3, so we're going left 3. Okay, we're going to the left 3. So that's negative 3 for our x value. So negative 2, negative 1, negative 4, negative 5. All right, so negative 3 plus 3 is 0. 0 squared is 0. Negative 2 plus 3 is negative 1. Squared is 1. Negative 1 plus 3 is negative 2. Squared is 4. And so we can mirror it to the left. All right, so we have a point at negative 5 and positive 4. We have a point at negative 4, positive 1. We have a point at negative 3, 0. We have a point at negative 2, 1, and negative 1, 4. All right, and there's our graph. Okay, we shifted it to the left 3. All right, we're going to go on to our next page now, and we are going to combine, and we're going to do multiple translations of the same function. So now we're going to be going horizontally and vertically with our movements. So we're going to have to do some work with that. All right, so we've got f of x equals x squared, and then we've got g of x equals x minus 2, the quantity squared, plus 1. So what do we need to do here? We're going to start with what is happening. Well, we have a minus there, and we have a plus there. So what are we doing? We are going to go right 1, and we're going to go up 1. That's going to be our translation. We're going to go right 1 and up 1. So if we're going to move to the right 1 on our x values, okay, we were at 0. We're going to move to the right 1. We're going to go right 2. I don't know why I said 1. We're going to go right 2. All right, right 2. So now, if we're going to the right 2, our new x value is going to be at 2 for our y-intercept. And we're going up 1, our new y value is going to be 1 for the vertex. And if we substitute it in, 2 minus 2 is 0 squared. 0 squared is 0, plus 1 is 1. All right, so now we have 2. We grab a couple points on either side. We've got a 1 and we've got a 0. All right, so 0 minus 2 is negative 2, squared is 4, plus 1 is 5. 1 minus 2 is negative 1, squared is 1, plus 1 is 2. And we mirror that to our right side. And now we graph. We have 0 and 5. We have 1 and 2. We have 2 and 1. We have 3 and 2. We have 4 and 5. Okay? All right, now we're going to go ahead and put in our curve. And it gave us a curve. Not quite perfect, but there we go. And so we have our graph. Letter B, what's happening? Well, let's look at it. We've got a plus 3 there, and we've got a minus 2 on the outside. So the outside one is pretty easy. We know we're going down 2. And that plus 3, remember, that is that minus negative 3. So that's a left 3 that we're going to move. We're going to move left 3. So we're going left 3 from our vertex. So that means our new vertex is at negative 3. That's our new starting point. And we're going down. We were at the origin. We're going down 2. So it's negative 2. Negative 3, negative 2. So we're going to go negative 2, negative 1, negative 4, negative 5. All right. So negative 2 plus 3 gives me negative 1. Sorry, negative 2 plus 3 gives me 1. 1 squared is 1, minus 2 is negative 1. Negative 1 plus 3 is 2. 2 squared is 4, minus 2 is 2. Negative 4 plus 3 is negative 1. Squared is 1, minus 2 is negative 1. And then negative 5 plus 3 is negative 2. Squared is 4, minus 2 is 2. So if we have our points that we're going to graph, we have negative 5 and 2. So negative 5, positive 2. We have negative 4, 1. We have negative 3, negative 2. Sorry, that was negative 4, negative 1. So we have negative 5 and 2, negative 4, negative 1, negative 2, negative 1, and negative 1, 2. So there's my points there that I can graph from. And we have our U-shaped graph. Okay, your last 2 problems on the page are U-tries. Go ahead and do those 2 on your own and then come back and check your work against mine. All right, letter C. we need to look at our equation and see what's happening. So we have a +1 there, a -1 there. So let's just remember this is minus -1. So it's a -1. So we're going left 1 and we're going down 1. And our origin, or the origin was our first point for this one. So if we go left 1, that's -1, and we go down 1, that's -1. So we got 2 points, 0, and why did I do 2? 0 and 1, and then we've got -2 and -3. So 0 plus 1 is 1, squared is 1, times 3 is 3, minus 1 is 2. 1 plus 1 is 2. 2 times 3 is going, or sorry, 1 plus 1 is 2. 2 squared is 4, times 3 is 12, minus 1 is 11. And we can reflect those two values to our left as well across the axis of symmetry. So we have a point at -1, -1, which is right there. And then we have our next point at 0 and 2. And our next point is at 1 and 11, which will put it about up there. And so we can reflect this point, -2, 2, and -3, 11. So it's approximately right there. All right, and then we go ahead and we graph our curve. And there we go. All right, our last problem, x squared. Let's throw in our quick reference points here so we know what we're looking at. So now we are shifting this one. We're going to go, we have a -2 there, we've got a -1 there. So we're going to shift this right and right 2 and down 1. So right 2, down 1. So now we went from 0, 0, we went to the right 2, so now it's at 2, and down 1, -1. All right, so now we have 2, 3, and 4, we have 1, and we have 0. I always like calculating with 0 and 1 because they make it a little easier for me to work, so, but that's when it's in the full form. Let's do it with the other ones on the positive side. 3 minus 2 is 1, squared is 1, minus 1 is 0. 4 minus 2 is 2. 2 squared is 4, minus 1 is 3. And so we reflect with 0 and 1 as our inputs there. All right, so we're at, let's see, 2, -1. We're at 3, 0. We're at 4 and 3. So those are that points. We've got 1 and 0, and we've got 0 and 3. So there's our graph. All right, and that is the end of the notes for today. If you have any questions, please bring them to class. Otherwise, I hope you have a great day.